Yes. I guess we are live now. Yes, for sure. Okay. Hello, everybody. Welcome to the third edition of FlameCon. I'm really thrilled. I hope everybody is as hyped as me for this edition. We have some nice talks to see today. As a summary, today we have a new collision detection system by Lukas Klingsbo, Flame View 1 news from Luan, and finally, last but not least, Flame on Raspberry Pi with Christopher. So I guess I can invite Lukas Klingsbo, also known as Spydon, here for the first.
Hello.
Hello, welcome.
Sorry for my cam being so super blurry again.
Yeah, for 1 second I thought I was not seeing clearly stuff, but I guess a focus problem. Okay, you want to share your screen?
There we go. So if you pull it in.
Okay, I'll leave it to you now.
Yeah, well, I guess I can start by presenting what the new collision detection system is. So if you haven't watched any of our earlier streams, you have heard about Forge 2D, which is like a full-blown physics engine. But now this collision detection system that is built into Flame V1 is so that you can, yes, sometimes you want to do much simpler things than not having a full-blown physics engine. If you, for example, just want to see if your two sprites are overlapping or something like that, and you want to do something if they overlap. Or if you say that you have a sprite shooting something and then you want to know if that shot has hit something. So this is what this new collision detection system that is built into Flame is. So I was going to do some live coding here, and of course I haven't set up everything yet, but I'm almost there. Just going to remove all the sheet code that I have here. Okay, so we're going to start off with a little like skeleton of a game here. Let's see, and we call it Ember game. Ember is the little mascot of Flame, if you haven't heard of that one earlier. And extend base game like we always do. We're going to have a player in there. We're going to have a little parallax background. And none of this is something that we're going to go through now, since we will focus on the collision detection system. And we're going to have some enemies and a player. So we can start run this in the web first to see how it looks. Okay, I have to remove all this first. Okay, now let's try to run it. Compiling. How is the sound? Is it a good volume? Oh, everything is so smaller. Let's see. Yeah, seems like it. Okay, I think it's starting Chrome. Take some time. All right, now let me share the Chrome window instead. if you can pull that one in and on. So this is just what we're starting with, what we're gonna build from today. We have a little animated player here that is, I don't know, freezing in space or something. So it's trying to destroy these big ice cubes here. And as usually, it looks more laggy on the stream than it is when you're running it. Yeah, so like if I just go here now, like nothing happens. But what we want to do in this game is that the player should take some damage or something if these ice cubes reach it. And we want these little ember things that it's shooting at the ice cubes to make the ice cubes get damage. So let's try to do that. Then we can pull in the IDE again. Oh, what now? It thinks I have blocked screen sharing here. There we go. Now you can pull it in. Now. I hope. Okay, so let's start to look at this ice cube then. So it's just a normal sprite animation component, and it has a position and a speed that is like going closer to the player, and it's rotating. But none of these things we need to worry about now. So to add, make it collidable, we need it to have a hitbox. So then you just write with hitbox here, and with collidable. And to do the simplest, absolutely simplest hitbox, then we can just add a square around it. So then you do add shape in, for example, your onload method. And you add an empty hitbox rectangle. So an empty hitbox rectangle, that means that it fills the whole component. So we can do this for all of our, or actually we don't have that much time. So if you looked at how the like embers were looking at the things we were shooting, they were kind of round, and they're kind of filling up the whole size that the component has. So here instead we can add a circle. And we want that one to fill up the whole. Oh, it's complaining. Guess I have to import something. Oh yeah, and this one we also have to make collidable and have a hitbox. And what do we have more? We also have the player. We can start with having the player as a rectangle too. And then later we will make these ones more specific to the actual shapes that they're having. And also when you're adding hitboxes, all of your things like draggable and tappable and things like that, they will be more precise. So because Flame will know if you're dragging within something that is supposed to be what your component is representing, or if it is because your component always has a size that is a square, right? But your component doesn't necessarily always have to fill that square. Okay, and then we can turn on debug mode so we can see how all these things look. Okay, and let's run this. Okay, that's... Oh, yes. So here we got an assertion, and it says that you can only use the hitbox collidable features with game that has the has collidables mixing. So on our game, we have to add a has collidables here. And that pulls in the whole kind of collision detection, because it doesn't run that if you don't have this. So now we can try to run it instead. That was more luck. And I will swap around the screen share again. Oh. All right, can you pull that one in, Hanan? So like you see here, we have now we just have rectangles around these ones. And we have, oh, it's very hard to see on these ones, but it's circles on them. We can slow them down in the next iteration and to be easier to see. So these embers, the little fiery things, they actually have a pretty good hitbox right now with just a circle covering that their like outer size rectangle. But if you look at the player and these ice things, for example, they have pretty bad hitboxes. So let's try to improve those ones. So back to the code again. All right, can you pull that one in? And there we go. So first of all, we can start with the ice cubes. So if you remember how they look something like, they have one round part and one pretty square part. So we want to add two shapes to this hitbox, one circle and one square. And the good thing with the hitboxes here is that they're not dependent on the size, or they are, or rather the other way around, they are only dependent on the size. So when you define them, after that you can resize the component and the hitboxes will still be correct. So if we start with this ice cube, and actually I pull in what the hitbox should be there. Whoop. So now we remove this rectangle that covers everything. And here, now these ones are not empty anymore. We define, for the rectangle first, we define a relation. And this is the relation to the size of the component. So it should be as wide as the component is, which you can see here on the. So this is a sprite sheet with 3 sprites, and it will be split just here. So the square cube up here, that one is as wide as the component will be. And then we want the height to be approximately half of it. And if I only write this and add it, it will add it to the middle of the component. So we want to like offset it a bit. And that's what we do with the relative offset here. And that one is also relative to the size of the component. So this one like pulls it upwards by like half the component. And then we do kind of the same thing with the circle. The circle, we want to have the full size. It takes the largest size that it can get, which is the width now, since the height is much longer on that sprite. So we don't have to define any relation here. But if we would want to have a smaller one, we have a definition here. And since it is only a circle and not an ellipsis, you only have to have the radius relation here. So if you want it to be half of the size of your component, then you just write like that here. But so that one, we just put the relative offset with 0.5. That's odd. Oh yes, because this relative offset is minus 0.5, so that one is upwards, and this one is 0.5 downwards. So if we run this now, we'll be able to see those hitboxes. Okay, so here you can see that it has this round circle here and a cube here. And we could move them a little bit to make it even more perfect, but it's good enough for now. And when you do your own hitboxes, make sure that they stay within the bounds of the component, because the parts of the hitboxes that are outside of the size will not be checked in the collision detection system. So you see there's a little tiny part here that is outside. If something would hit that part, it wouldn't detect it. But if it's like a few pixels inside, then it will detect it. So then we can try to do a hitbox of this little more complicated figure we have as the player. So back to the code again. Let's see. Oh, we have some comments here too. Okay, someone is liking Wolfenrein. That's nice. Okay. Right, where were we? The player, to make a hitbox for that one. Right now we only have the hitbox rectangle here, so we can remove that one. And if we look at one of these images, we can see that for the head, we could probably do a circle too. It would be good enough. But for the body, it wouldn't really fit with a circle or a rectangle. So for that one, we'll use another shape that we haven't used so far, and that's a polygon. And that one, it's a little bit more complicated to define, but you can get much more accurate collision detection with it. And I have prepared those ones too. I'll explain them, pull them in here. Oh yeah, and if you haven't used the sprite animation group component, it is super handy because you can have several animations, and depending on what your player is doing, you can easily swap over what state it is in. Like here I set it to state to being idle in the beginning, and then when I'm shooting, for example, I set the state to be shooting, and then it just swaps the animations automatically, which is very handy. Something Eric has built. So here we have the head then. It's defined similarly to how we defined the circle before, but since this one is not covering the whole width or the whole height, we don't want the circle to be a little bit smaller. So it's hard to see where the edges go here, but they go something like this on the image. So we want to have that one like 60% size of the size. And we want it to be, so this is the x-axis, right? And this is the y-axis. So we want it to be half of the 50% of the component pulled upwards, because yeah, the head is on the top, and a little bit to the left. And then we have the hitbox polygon, which is, so here you have to put a list of points within your component. So it's, yeah, that one is easier to explain when we actually see how it looks. And that one you can also like move around within the component after you have defined it. So let's run it with that. And this is a pretty rough polygon. You can do much more complicated ones if you want better collision detection. But for this game, this will do. So here you can see how the polygon is defined. And now you can also see that I can't drag the player like out here, but I can drag it in here. So the like I said in the beginning, like the draggables and the tappables, they're also improved by adding hitboxes. Let's see, what time is it? It's 20 past, so I have some more time. So this one is moved down a bit, and then it's for some weird reason, when you define hitboxes, you want to define them counterclockwise always. It has something to do with how the algorithm is done. So remember that when you do the polygon hitboxes, that they should be defined counterclockwise. So this one is, let me turn off these enemies so that they're not on top of everything all the time. Okay, there we go. There. Where were I? Right. So what we had here in the list was, for example, it started with like minus 0.5, minus 0.5 or something. So that means like go straight up to the left. And you have to remember that this one has been moved down, this polygon. So it's started around here as and all of the shapes for the collision detection are defined from the center. So not like the components that sometimes can be defined from like any anchor. These ones are always defined from the center. So you have like the minus 0.5, minus 0.5, and then here you have maybe minus 0.5, and then plus 0.7 or something, like, because you go down and then you go around like that, all these 5 points. So we have 1 point specifically for the knee here, but you could have like 1 point here, 1 point here, 1 point there, and so on. But then if you have super complicated polygons and you have a lot of components that you want to do collision detection on, then it will probably perform pretty badly because it's not very optimized for complex polygons yet. Someone on Discord is asking me to show my keyboard, apparently. But my, yeah, I'll do that afterwards. What more do we have? Yeah, you can set your different collidables as either passive or active or inactive, I think I called it. So that means that, like, all of a sudden, if one of your components shouldn't be having collisions, then you can set it to inactive. Or if you have a lot of components that shouldn't collide with each other, for example, like these shots that these ones are shooting, then you can set it to passive. And then the active ones, they will collide with both the active and the passive ones, but the passive ones will only collide with the active ones. So if you have like a lot of things that are collidable, you should see if you can set them to passive instead of active, then you will get a bit better performance. Yeah, and I think that's about it. We can just turn on the real game that was, or the real game, the small little game that was built out of this afterwards. And I will put up the link to the Git repository and stuff so you can play around yourselves. Let me see if I can get that code back that I removed. Okay. Oops, 2 seconds. Where did I hide the code? Okay, there we go. Now it's back. And let's put it back in Dashbook. And let's run it again. Okay, Chrome is waiting. Oh, I can swap the screen first at least. Ooh. So, and I will put this one up later so you can play around with the result too, so both the code and result. So now you can see we can like shoot our little things here, and when they hit something, they shrink. And this we do with just adding the on collision or on collision end. We override those ones in the components that we have with collidables on. So there you can do whatever you want, how you want to act on it. Yeah, I guess we can take some questions then.
Okay.
Around half an hour. Yeah, Henan is back.
Yes. I don't know if that's a good thing, but yes, I'm back, and we can take some questions now. We have some already. There's this one. So there's only two groups, the active and the passive. Is there a way to check on the shots against ice cubes and their ice cubes against Shaktars?
Yeah, indeed there is. So I actually forgot to show that. That was quite an important part. So I'll share the code and the IDE again. We can see that. It is pretty easy, and you mostly use internals of Dart. If you pull in the coder again, if you look here at the ice cube that we have, for example, we have, looking at the wrong one. So here we have the on collision one, and in this one we get the intersection points that if you don't do something quite advanced, you don't have to use them, or if you want to like know where on it collided.
Nice.
But then as the second argument you get other, and then you can compare what type the other collidable is. So here I check like other is Ember 4, which is these things that we shoot here. Or if we look at the player, for example, you can see on collision here I check is other the ice cube, then we do something. And here you can of course have many comparisons against the types.
Okay. So I guess this opens like infinite possibilities of a combination between kinds of stuff, right? Okay.
And then you can also, one more thing, you can also put these checks on the hitboxes instead of on the collidables. So if you want to check, for example, when we had this one, if you want to check the hitbox that was the head, that was the circle, then something you might want something to happen when it's hit in the head, or something when it's hit on the body, then you can put the different collision detection on those two. All right, next question, I guess.
I guess so far that was the only one.
Okay.
Of course. Yes.
Yeah. Exactly. So just like I added one circle and a polygon, you can add many polygons, which is sometimes easier than making one weird polygon, because the polygon also has to be convex. So which means that it cannot like go inwards, kind of, because then the collision detection doesn't work.
Yes. I think if you don't have any questions, you can think about your question, but I have one actually that I just thought about it. So we have something about quad trees. Yeah, have you ever heard about that?
Mm-hmm.
Yes.
Yeah, so we're not using quad trees or anything like that in our collision detection right now. Right now, we're only comparing
vectors,
like center points and sizes, kind of. As the first comparison, and then we do. So first we have could these possibly collide? Then we can compare them. If they couldn't possibly collide, then we don't have to compare them. But then
Okay.
yeah, you can do more advanced trees and stuff. Oh,
Yeah, I think combining the rectangular shape, we could have like something like that. Okay.
yeah.
Next question: will collisions be packaged into Vanilla Flame 1.0?
Yeah, so it is already available since RC9 on Flame 1.0, but I highly recommend that you run RC11 because it's it's in much better shape in there.
It's much better improved. Yeah, it's like a preview on 9, and 11 is more of the real stuff. Okay, yes. So short answer, yes, it will be there. You won't need to add anything else.
It is already there.
Yes, and talking about 1.0, next talk will be about V1 news.
I have to.
Yeah, we have to show our keyboard.
Exactly, but I am still super blurry, am I not? Oh well.
Yes, we just pretend we are all,
Maybe it will be better when I'm pulling it up here. So if anyone wants to build their own keyboard, these ones are called Dactyl Maniform, and your life will change once you have built one. They are awesome.
It will change. I don't know if it's for the better, but it will change. Just kidding.
Okay. You can get blurry camera with it.
Yes. And talking about V1, that's a nice segue for the next talk. So goodbye, Spydon. And now we have only you and me, and some seconds on you. So you're going to talk about some news on V1. Okay.
Yes, exactly. And I want to get this out of the way. I have a regular keyboard, so if that's a deal breaker for you, I'm sorry, but
it's not split, so okay.
No, it's in one piece. Like I never dropped it or anything, so it's not split.
Okay, I leave you to it.
Okay, so let me share my screen here. Right. So let's talk a little bit about V1. So as last time, I'll give some updates. You might already know some of the stuff that's going on because you're all following along in our channels. But I would like to basically give a summary of where we're at right now, what we did, and where we're going. I'll try to keep this as brief as possible because I know, I'm also here just to watch the other talks, and I'm really interested in what's in the next one about the Raspberry Pi. So let's get right to it. So first of all, let's always start with a little bit of history. So going back in time, we did this kind of V1 announcement where we showed the news on V1 on the last edition of FlameCon. And I remember I shared this image at the beginning of that talk where I said, look how many things there were, right? And I tried to go over at least most of it in that talk. And that already took some time. But then if I were to do this again, this is the new list only with the new stuff. So it's slightly bigger. So we've been busy for sure. The entire community has been helping so much with all this stuff. So this time I won't go over every single bullet item in that list, which is already not complete anyway. But instead, I'll try to summarize like the biggest changes, and I'll divide them in some categories. So I'll try to like highlight the biggest points that we have in each category. So the first one is slow and steady. So these are like the smaller things that we've been doing for a while. So it's not specific like big things, but we've been working a lot on these areas. So it's always good to mention. And the first thing is API cleanup. So we've been focusing a lot on like improving our APIs and making sure they're ready for V1. And what that means is making them uniform, consistent, making sure they make sense with each other. They interop nicely. They work well with our packages on the ecosystem, and so on. So that includes, for example, introducing Vector 2, where it used to be something else. So making it easily to play with all the other APIs. So if you have, your position component has a Vector 2, you can like pass that around to other APIs that will also, so everything will work with Vector 2. The same thing for anchors. So if something makes sense to be an anchor, it's now an anchor. Another thing, we made extension functions galore. So we added a lot of helpers and things to convert one thing to the other. So we know in the Flutter ecosystem, there are sometimes multiple classes to represent similar concepts. So we have extension functions to convert one thing to the other. And also helpers to like interop like Flutter concepts with Flame concepts in a very neat and easy to use way. And finally, we're also standardizing some constructors and ways to create components. So you might have seen some of this work already on like our components hierarchy tree. Like all the constructors now have the necessary parameters, so you can create them. So this is basically API cleanup. It's one of the things that we did a lot and are still doing. The next thing is tests. So we had some tests before, and I want to preface this by saying I don't think at all that like coverage or lines of code is like a reliable indication of anything, but it's some sort of metric, and we did grow our lines of codes of tests by more than 3 times. So everything that we're doing new, we're having tests. Any bug, we're trying to add tests, and we're also having tests for some old stuff that didn't have. So this is also one of the great improvements of V1. Like, we want to try to make sure at least all the core functionality is well tested to the limits of what you can test, right? Like you can have like some things are just drawn on the screen, so it's very hard to test. But anything that involves logic or operations, everything should be tested. And the final thing in this category is bug fixes. So we did many bug fixes. Most of the items in that gigantic list that I show, the changelog, are bug fixes. And of course, as you guys keep opening, issues on GitHub, we keep finding stuff, and we'll keep fixing and getting the experience to a very good level. So this is the first category. But we also had some giant leaps. So we had some very, very big things that landed since our last V1 news. And I wanted to highlight those things in specific. And the first very big thing is no safety. So this was actually a multi-RC work. So we started back at RC6, and it took up to release candidate 8 to get this fully complete, but we're now 100% no safe. Our dependencies that the Flame itself uses are no safe, and we're slowly migrating also all the other packages like in the ecosystem to all be no safety. I don't think I need to explain why this is so important and such a great improvement. And that is definitely now available on V1. The other thing is the simple collision detection, which I'm not going to talk about because we just had a talk about it. It's basically what Spydon showed us, and he's been working a lot on this. It started on RC7, but there's been many improvements ever since. And as you said, this is different from Forge2D, which has also been working on, which is a totally separate endeavor, which is a huge package for a much more complicated physics engine. I added a video here about showcasing like how the objects collide and exchange colors, but we already saw that, so I'm going to go past that. The other giant leap is viewport and camera. So we finally have built-in support for both viewport and camera, which will allow you to make much more complex games very easily. Any game that's slightly more complicated probably needs to use some of these concepts. And before, of course, you could do something yourself. And we did. And in fact, this was born from one of our games where we had a very similar concept, and we kind of extracted into a generic version, and we included that on Flame. So now it's built in, and you can control the camera, follow a character. You can use viewport to have a fixed resolution, so your game looks the same no matter the device. And that's super useful now that we have support for web, for possibly desktop and multiple devices with different sizes. So viewport can help with that, and also camera. Like if your world is bigger than the screen, which is true in most games, you'll be able to move the camera around very easily with this feature. And that leads to our final giant leap, which is a total overhaul of our gestures system. So the input system, the system where you detect, taps, drags, mouse movements, we overhaul the system. And what that means basically is that now it's much easier to use and is integrated with camera and viewport. So we kind of wrapped, so we still use, Flutter gestures as before, same thing, but we kind of wrap that around and we have our own classes now, and they are camera and viewport aware, right? So when you move the camera, you can easily, you can know the coordinate in the world system, right? So instead of getting the pixels on the screen, you can know the position on your map, on your road, considering camera and viewport. So this is also a great improvement that was enabled by the previous one. And this is also a huge breaking change, and probably one of the last ones, probably the last one this big that we plan to do, which means we're very ready. And that leads us to our final category, which I'm calling remarkable in-betweens. So it's just some smaller things that are not as big as the previous ones, but I wanted to list them so at least they don't go unnoticed. We added the isometric tile map, so just like a built-in component to help you out if you want to make an isometric game. We had hoverables, so similar to tappables and draggables that we had before. Now with desktop support, you can have hoverables, which is exactly what they sound like. If your mouse is over them, you get a Boolean to notify you. I have also been working on some improvements to order set. So that's a library that we use underneath that handles the list of components. And there are some performance optimizations that we're bringing to that. And also a lot of refactorings. So 3 bigger ones to name a few. We did some overhaul in the text APIs. We made them more in line with the other APIs, more consistent. Also the parallax APIs and the joystick APIs. So these are the main changes that we have for view 1. And I think we're very close to actually launching. We were actually talking about it, and we have 2 or 3 specific things that we want to tweak. And these are probably going to be the last ones. We're also waiting for feedback from the community, so you guys, basically. So if anything pops up and someone says, oh, this API is not as good as it could be, that's also feedback we want to take into consideration. But I think we're very close. And yeah, that's all, folks. Well, not quite. I also have a few surprises. So first thing we changed, I saw that, Hannah. So the first thing we changed is we now have a mono repo. So basically we moved everything to the same package, the same repository on GitHub. And what that means is that we have a single place where you can find Flame source code. We also have all the examples on the same place. We have the tutorials and the docs. And that brings us to these new things that we have. So before we had the docs, but they were kind of outdated with view 1. We have been working hard on improving the docs. I'm pretty sure we got most of those up to date. If you still find something that's not updated, please let us know, because we'll fix it right away. I think we're very close to having full documentation all updated. And that is on the same repository. And the same repository has the examples, which basically means if we make any change and that impacts any examples, we can change and fix the example on the same PR. So it's much easier moving forward to know, if we're making something that can be a potentially breaking change, we'll know right away because our examples will break, right? So now we have the code, the tests, and the examples all working together on the same repo, on the same build system. And finally, we also start having some tutorials on the mono repo, which is a very dedicated way. The examples show specific features, but if you want to learn from scratch and you want to learn about all the important features, tutorials are a great way to do it. They're still work in progress. I think there are only a couple for now, but we plan to focus on that as well. And one cool thing to notice is that the examples, well, actually everything here is live on our website, but in particular, you can access examples.flameengine.org. and you'll be able to play with all these examples on your browser, or whatever you access the website, like on desktop or mobile, your preference. You'll be able to play with all these examples in real time. So that's one of the benefits of the monorepo. The other thing that we're bringing to the monorepo are the bridge packages. So I talked about this a little bit last time. The bridge packages are basically the packages that interrupt Flame with something else. Right, and this something else can be basically any other library that has to have some connection with Flame. So some examples of bridge packages that we're working on, for example, Flame Audio. I talked about this last time. So we have audio players, which is our library for playing audios that is used in all kinds of apps. And Flame Audio is specifically all code that connects Flame with audio players in a very easy and seamless way. Right, so now our bridge packages will be moved to the monorepo. As you can see, we did that with Flame Audio. We also have Flame SVG, that's also done. And we're currently working on bringing Forge2D tiled into the monorepo. Those are almost done. And we also need to work on Flare and Rive. So bring everything together in the same repo. Make sure all packages work together. So if you want to, I need SVG, I need audio, I need X, Y, like they all play nicely together. Being on the same monorepo will allow us to do that. Now, I actually haven't mentioned all the bridge packages because that's part of some of our surprises here. And the first bridge package that I want to highlight is Flame Oxygen. So that'll be released soon. Johan has been working a lot on Oxygen and Flame Oxygen. And as you can imagine, Flame Oxygen is just a package that bridges Flame to Oxygen. But you might be asking, what is Oxygen? Well, Oxygen is a brand new lightweight ECS framework. So ECS means Entity Component System. So you might be familiar with our Flame components, which we're now calling Flame Component System, which is loosely based in this concept called Entity Component System. But it's quite different. So I try to adapt that to a dark reality when I start building that. And it's a really nice way to structure apps. But it's not exactly the same as the canonical Entity Component System. But now we have that. So if you want to structure your games in the ECS framework, you're now able to do that using Oxygen, and you'll be able to use Flame Oxygen as a bridge package to help you integrate Oxygen, which is a Flame agnostic library. It's just an ECS framework, and you can bring that together with Flame and build awesome games using this really nice way of organizing your code into components and systems. So that's one of the things. The other bridge package that I haven't mentioned yet is Flame Fire Atlas. So this package, if you add that, allow you to import Fire Atlas resources into your game. And you might be asking, so what is Fire Atlas? So that's also another news that we have today. You might be familiar with it, but we and Eric has been working a lot on this. We basically revamped a lot of the tool, and you can see there is a little video there. Basically, it's a way to create your Spritesheets in a very easy and simple way. You just define regions of your images, and you'll be able to import all that information into Flame, so you don't have to manually specify this sprite starts at position X, ends at position Y. It'll be all done for you. And the great news about Fire Atlas is that now it's available for download for desktop as well. So using the power of Flutter, we're able to provide this. Originally, it was a web app, but it now just works on desktop as well. So you have two options now. If you want to download it, you're able to do that, or you can access on web as before. And I have some links here, I think. So you can go to our GitHub to download it. Available for all three platforms, Linux, Mac, and Windows, whatever you prefer, or on web, you can access via this link. Sorry. So that's our second bridge package that I was saving for later. And finally, I want to give you a sneak peek into two very interesting things that are not ready yet, but they are coming soon. And I think you guys are going to like this. So the first one is Ignite. Ignite is an idea that we have where like you need to start off a new Flame project, right? So how do you do that? Basically, it's a simple wrapper over the Flutter Create tool, but we're still developing, but the idea is that it's gonna provide you with many more options. So I have a little video here that I made using the tool. So basically, it'll create a new project for you. It'll automatically add Flame as a dependency, and you can pick a version of Flame, and you can pick a template. So you can make a very simple game. You can add some code. You can have like an example game. So very similar to how Flutter creates your Flutter project with some guiding comments and some initial code. But you cannot change that with Flutter Create. This will basically let you pick some options that will replace those initial files, so you can very easily bootstrap a new Flame project. You can see you pick some options, and then it just creates your project for you. And then you can go inside a folder, and you can see like the Flame dependency is added for you. You just have to pick the version. And this one I use the simple, so you basically create your pretty standard run app with an empty game, but you could choose other templates, right? So you can imagine how we can explore this idea and add a lot of cool stuff to this new tool. So watch out for that soon. And the final sneak peek, and this is the last thing I have for you, I promise, is FlamePad. So again, this is also not ready yet, but we're working hard on this. Especially Johan, also known as Wolf and Brian. And what this is, we'll just show it because it's so awesome. And you can just watch this video. So yeah, this is the same example as before. We've seen this many times. It's the simple collision system. But where is it running at? What's this code here? This is basically Dartpad, but for Flame. So we'll be able to, on your browser, run a snippet of a game, and you'll just see the effect in live code, like just like Dartpad, but with a Flame game. I think this is really cool. Yeah, that's all I have, I think. This is my last slide. Yeah. So that you can come now, and
Wow, so many surprises and sneak peeks. It's like, wow, too much for me. Oh my God.
I'm really excited for the future.
Yeah, me too. I'm already excited about what we have now in the present, even more things that are to come. Okay, just to notice two things. We have some questions there in the chat, but we are gonna focus on answering those questions after the next talk and next talk's answers. Yes, and second thing is we are going to paste this links and stuff like that also in the video description for the eternity. I dropped one link for the examples in the chat, but all of these links that we have, we're gonna be on the video description. So yes, Christopher, hello there. Are you ready? I hope you are. And you are muted. He's still muted. Nope. You can do sign language as well. I won't understand, but okay, it's working now.
All right.
Hear you now.
Nice.
Awesome.
All
Okay.
right. So goodbye, Luan. And I leave you to it. Christopher talking about Raspberry Pi and Flame. That's good. That's interesting.
Okay, so I put a link to the repo in the chat.
Okay.
In case you all want to follow along. And it should also have a link to my slide deck.
Okay.
All right, let me now share my screen.
And I will leave it to it.
All right. All right. Okay. Hello, everyone. I'm going to do a talk on Flame on the Raspberry Pi. And I'm really excited to be at FlameCon version 3. And yeah, just wanted to thank the whole Flame team for having me. And yeah, the other 2 talks were really great too. So anyway, if you want to follow along at home, I have a repo with links to the slide deck, and it has all the code that I used, so you can check that out. All right, so my name is Christopher Fujino, and I live in Sunnyvale, California. I work as a release engineer on the Flutter SDK, and I never got a Super Nintendo from Santa in 1992. I don't remember what I actually got, but I just remember that it wasn't a Super Nintendo, and so I wasn't playing, you know, Super Mario World and Street Fighter 2. And as I was preparing this, I was thinking this might be why when everyone else during the pandemic was excited about this, I was the most excited about this. In case you don't, if you're not in the know, this is Stardew Valley. There was a 1.5 update. This is the desert island. So I love retro video games and retro styled video games. And it seems like right now there's just an incredible resurgence of indie game developers who are creating video games inspired by you know, my childhood. So it's really exciting, and that's part of why I really love Flame. Okay, so what are the objectives of this talk? As I was saying, like, I'm interested in retro console style games, the type that you would play on a Super NES. I wanted to try to use the stable Flutter and Flame versions. I didn't want to have to like hack either of these SDKs in order to get it running. I wanted to use the out-of-the-box Flutter tooling. And I wanted to be able to build and run the game from the Raspberry Pi. Oh, and most importantly, I wanted to have fun. This is for fun. This is not for profit. And I just, yeah, I just love playing around with Raspberry Pis. Okay, so the one live demo that I'm going to give is of the game that I will be using. I had thought about building my own game, but I'm very glad I didn't. Instead, I took the, I think it's the Fire Slime shooter game. And it is a submodule on my repo. And it looks like this. Uh-oh, it's pulling it up in web. I actually wanted the mobile version. Here we go. As you can see, I'm a Vim user, so I don't use the IDEs, which will become relevant later. All right. I don't see, it says it's running, but I don't see it. Oh, here it is. Okay. Here's my emulator. So it's a basic shooter game that has, and this is, I use the fork that the Flame team uses as their performance test game. So you can see in the upper left corner, it has the frames per second. And below that, it has a count of all the objects that are on screen. So since this is running in debug on an emulator, I'm getting around 30 frames per second. But if you run this on a native device, you can get 60 frames per second. And it has a touch UI. So since I'm in the emulator, I can use my mouse to click around and shoot these aliens. All right, so that's our app. And if, let me also just show that you can also run this game on desktop. So this is, I'm on a Linux computer. So I just passed Flutter run -d Linux for the Linux device. I will note that in order to get this game running on desktop, all I had to do was enable desktop in my tool and then run Flutter create in the directory. If you just try to run it as a desktop app, it doesn't have the necessary, the scaffolded out Linux desktop files. But if you just run Flutter create again in an existing app, it will, and you've enabled platforms that aren't existing, the tool will create them. So as you can see, it works pretty similarly. It uses, works pretty, the UI is pretty much the same because I'm using my mouse right here. And it's a little bit different in that it's wider because it's a different, it's landscape rather than portrait. And as I was working on this, I found out that with mobile Flutter games, you can force the orientation, but with a desktop game, you cannot. But anyway, there we go. It's running at about similar frame rate, a little bit higher. That might be because I'm streaming though. I was getting higher frame rates earlier. Okay. Anyway, so that is our game. And that is the last live demo that I'm going to do. Everything else I pre-recorded. Okay. All right, so let's talk about Flame on the Raspberry Pi and what this means and what it will take to run a Flame app on a Raspberry Pi. So first, we're going to focus on Flame. What is Flame? Now, if you don't know what Flame is by now, I can't really help you. But I think it's important to call out that Flame games are 100% Flutter apps. What this means is that anything a Flutter app can do, a Flame game can do. And it also means anything that Flutter doesn't support out of the box, Flame will not support out of the box. Okay, so let's drill down even further. Okay, what is Flutter? Flutter is a UI toolkit for building beautiful natively compiled applications for mobile, web, desktop, and embedded devices from a single code base. And for the purposes of this talk, we're going to focus on desktop. Okay, but first, just look at this diagram. Probably most of you have seen this diagram or something like it. This is showing the architecture of the Flutter framework. So at the very top of a Flutter app is going to be your custom code written in Dart. Below that is the Flutter framework, which provides widgets, gestures, etc. I will say with a Flame game, you could think of the Flame engine as being alongside the Flutter framework. It also depends on some of these primitives that the framework provides, but it is also giving you Dart level features. Below the framework is the Flutter engine, which is mostly written in C++, and it also includes the Dart runtime, and it also includes Skia, which is the graphics engine. So all of this pretty much we're just gonna use out of the box. Below this are the platform-specific embedders. So this means for every platform that Flutter supports, that's like Android, iOS, Windows, macOS, all of these kinds of platforms, they use the same Flutter engine code, but they have their own embedder. And so for this talk, we're going to be focusing on Flutter's Linux embedder. Linux desktop embedder, I should say, since Android also uses Linux, but the embedder is completely different. And finally, at the bottom, the bare metal is the hardware that we're using. Okay, so Flutter for desktop. This is currently in beta. It is in beta. You can access it from the stable channel, however, but you need to explicitly enable it with Flutter config -- enable Linux desktop or something like that. There's support for Windows, Mac OS, and Linux. Specifically, the Linux embedder depends on GTK, X11, and OpenGL. And there is experimental support for Linux ARM64. So this will work out of the box. Well, it may work actually, but there is support for it. It has not been rigorously tested, so which is part of the reason why I did this talk. It's like, okay, let's see how this works on the Raspberry Pi. However, one question that I had going into this is, well, what exactly is ARM64 mean? Oh, sorry. It's bad transition. I should mention a really cool project, Ardera's Flutter Pi project, which you can check out on GitHub, which is a lightweight Flutter embedder for the Raspberry Pi. So it does not depend on GTK or even X11. It supports both ARM32 and ARM64, and it's distributed with pre-built binaries. This is a really cool project that, honestly, I didn't even hear of it until I started working on this. And so I did not get around to actually trying it, but I know that there's active development on it. It seems a lot of people are playing around with it. It seems very cool. And it's operating at a lower level than what I'm going to be demonstrating, because it doesn't, depend on GTK or X11. And so I would imagine there's a potential for even better performance with this. However, as I stated previously, I was really looking at seeing what can you do out of the box with Flutter and Flame. And this has external dependencies. You have to run special tooling for this. So that's why I did not use this for this talk. But yeah, it seems like a really cool project. And another project by Sony is Flutter Embedded Linux. This project uses Wayland. So it also doesn't require GTK or X11. And it's tested with multiple ARM64 devices. So it doesn't, at least hasn't been tested with 32-bit, but it does support other devices other than the Raspberry Pi. It doesn't have pre-built binaries, so you have to compile the binaries from source. And this is, I have to say that the Sony team has been working on this. They've been contributing design docs. They've also been upstreaming changes to the Flutter SDK. The fact that you can run the Flutter command line tool on a Raspberry Pi is because of changes from the Sony team. So they're doing really exciting things. I also did not get a chance to play with this embedder, but I plan to at some point. Yeah, so I just wanted to give them a shout out. Okay, finally, so what is ARM? And there's a really great conference talk on YouTube called A Tour of the ARM Architecture and Its Linux Support. It was given by Thomas Pettazzoni, and I linked it, but you can just search that in YouTube and find it. And it's a really great, the speaker is a kernel contributor and has done a lot of work with embedded Linux. So he really knows this stuff. So I cannot do it justice. Please go check this out if you have any interest in like, okay, what exactly is ARM and what does it mean to support ARM? However, just kind of summarize ARM. So what ARM is it's a company that writes architecture specifications. So they don't actually, ARM doesn't actually make any hardware. They write specifications, they write implementations of them, and then companies generally will license these implementations and then actually build the hardware. And now some companies are writing their own implementation and then building those. So there's many versions of the ARM specification, such as ARM v6, ARM v7, ARM v8. For this talk, we're going to be focusing on ARM v8. Okay, what is ARM v8? It includes ARM v8A. There's two versions of ARM v8. ARM v8A, which is also, this is the more common one. So if some documentation says ARM v8, it's most likely ARM v8A. The other version is ARM v8R, which is real-time. This is for very special embedded use cases where it's absolutely essential that executions will run in order and run as fast as possible. Whereas with like most systems, the processor will try to be smart and prioritize things in the most efficient way. But anyway, that's what, if you see ARM v8A and you're like, what is that? It's just sort of the standard version of ARM v8. And the important thing with the version 8 specification of ARM is that for the first time, it includes support for both 32-bit instructions and 64-bit instructions. So the new 64-bit instruction set, it was named AArch64, which is a mouthful. So a lot of people just shorten it to ARM64. And then they've sort of named the older instruction set AArch32. And this is, for the most part, backwards compatible with ARM v7. Okay, I'm getting all bogged down. Let me just kind of run through this. But the important thing is that ARM v8 CPUs can run kernels that are compiled for either AArch32 or AArch64. So they can run either 32-bit kernels or 64-bit kernels. Okay. So Flame on the Raspberry Pi. Let's look at the Raspberry Pi side. So what is the Raspberry Pi? It's an affordable credit card-sized computer that hobbyists all over the world have used to create so many diverse, creative projects that have made the world a better place for playing retro games. And other things too, obviously. But I will say for myself, when I found the Raspberry Pi, I was like, oh, this is incredible. And I instantly built an emulation box. So, okay. So for this particular presentation, I used the Raspberry Pi 4B. So let's look at the spec sheet. Actually, I won't read the whole spec sheet, but I put in bold probably the two most important things for the context of this talk. First, that it uses an ARM v8 chip, and that it supports OpenGL hardware accelerated graphics, which means that it can, in theory, run Flutter apps. Okay, so what operating system are we going to run on this? And this was something that when I was thinking about this presentation, I really took for granted. Like, I used to be a Linux distro hopper, so I can figure out an operating system. I'm not really worried about it. But this actually turned out to be the most difficult part of this presentation, finding the right operating system to run on this. So now hopefully you can all benefit from this. So the TLDR is that the Raspberry Pi Foundation has an official operating system called Raspberry Pi OS. It used to be called Raspbian, which is a Debian-based operating system. and it only supports 32-bit builds, which is a problem because if you notice, the Linux desktop support for ARM only supports 64-bit. And this is really only, this isn't a technical limitation. It's just that's what the Flutter CI is building. You could build it from source, a 32-bit version. But again, I was trying to go with just out-of-the-box tooling. But fortunately, there is a beta version of the 64-bit builds, which are not documented on the website. I just found it from Google searching some message board. I'm pretty sure it's official, but it, yeah. And fortunately, it worked. I installed this on my Raspberry Pi, and everything worked. Okay, so yeah, again, I spent most of the time working on this, really getting everything set up. So let me just share with you everything that I used for this. Raspberry Pi 4B, the 8GB model. I didn't buy this Raspberry Pi for this presentation. I just bought it for myself because I wanted to see how far I could push the hardware. So that's why I bought the biggest, the 8GB version, which I think was like $80 or something. You could, I'm sure this would work with less RAM. And then I used Raspberry Pi OS, the ARM64 build. I used Flutter 2.0.0 stable. Oh, actually, that's not true. That's a typo. I used 2.2. Yeah, the latest stable. And then for Flame Engine, I used the latest release candidate, 11. And I used a Linux x64 desktop computer. Now, this is not technically mandatory, but the developer experience actually on the Raspberry Pi, I don't think you're going to want to do like actually write a Flame game from scratch on the Raspberry Pi. For one, I just think it'll be difficult running an IDE on it. Again, I used Vim, but and also basically with all my testing on the actual Raspberry Pi, I ran release builds. So I'm not sure what kind of performance you would get out of using the debug builds. So, and with compiling for release, it would take pretty long. I imagine probably because the Raspberry Pi, it uses a micro SD card for storage. So reading and writing is not very fast. So anyway, so actually like importing my game from mobile to desktop first, I did that all on my Linux laptop, made sure that it ran on desktop, and then I just took that code and put it on the Raspberry Pi and then ran it. So, okay. And then here is, and again, I am not a professional conference speaker, so I chose not to actually try to give a demo, especially with, you know, with like a Raspberry Pi hardware. So I pre-recorded actually running the game on and put it on YouTube. So let me just play this. So as you can see, I'm launching the game from the command line, running flutter run -d linux -- release. And yeah, the compilation takes a little while. Okay, and there we go. So I have my game running on a Raspberry Pi, and I'm using my mouse to control the spaceship. And it's kind of funny, actually. So I'm actually getting a better frame rate on that than my pretty powerful Linux laptop right now. I was getting, like in the 40s, 50s frames per second with that. And so I was really, really excited to have that working. However, there was just one problem with this. I had to use my mouse to control the game, that's not really being true to this retro style, console style game. Flutter for desktop also supports keyboards, but that's not really being true to the spirit of retro games. Really, what you want is, and do I have it right here? I do have it. You want to use a gamepad to play retro games. And I have this, I just had this lying around. This is a Logitech F310. I don't know how long I've had this, probably for 10 years. But so I was like, okay, I have to get this running on my gamepad. Unfortunately, when I went on pub.dev, I found that there were no packages, no plugins for Flutter that work on Linux desktop. So what I did, of course, was I Googled, okay, how do you support joystick in a Linux game or a Linux application? And the documentation I found was just like a text file in the Linux source tree that was written like decades ago. But yeah, so let me show you what I found. Basically, there's two ways for this particular, and I'm not a Linux developer, so I'm sure there are better ways to do this. This is just what I found from a Google search. If there's a way easier way to do this, please feel free to open an issue on the repo or comment. But anyway, from this doc that I found, there's two different ways to read joystick events. This is the first way, which is blocking API. So this is C code, by the way. So you open the device /dev/input/js0 as read-only. And then this joystick.h header specifies a special struct called joystick event. So you create one of those and then you pass it to the read. You basically will treat the joystick device as a file and you read one joystick event from it. Now, what happens if you try to read it, but I'm not pressing any buttons on my gamepad? Then this read call will block until it does get an event. So I got a proof of concept working with that. I was like, okay, this is cool. However, I don't know if I want to do this. Obviously, I can't block my game on waiting for gamepad input. So I would have to have multiple threads and then somehow have these threads communicating. And it's like, well, at this point, I am now a C developer, and which is not what the whole point of using Flame is, so you don't have to write C, right? So I didn't want to do this. Fortunately, there's another way to do this, which is to read input in a non-blocking fashion. All right, so how this works is when you open the device, you pass in non-block. Now, when you do the read operation on the file descriptor, it will either return an event if there is an event in it essentially works like a queue. So if I pressed a button and then after that I do this read call, it will return the event that I pressed. If there was if there wasn't a button press, see, I did greater than 0 here. I'm not sure if it was 0 or negative, but basically this read call will let you know there's no events, at which case you can just ignore it, right? But if there was an event, then I'm going to process the event. Oh, and I see. And then the way that this API lets you know that the queue is empty is by putting a special value into the error no value. So anyway, I decided to go with the non-blocking API because I thought about it like, okay, I already have a game loop, so I'm already doing these, I'm already running code very frequently. So I can just once per game loop call this code and check if there were any events. Which is what I did. Right. So this is now my Dart code. This is my Flame game. So in update, what I'm doing is I'm calling the flush file descriptor code, which is basically from the last slide, right? We're going to actually read the physical device and then see if there's any events there. And if the event is not a null pointer, then I'm going to process this event. And basically, this is sort of the key down here, which is player begin fire if it's a down press, or player stop fire if it's an up press. Okay. Now, how do you talk to a C API from a Flutter app? Well, there's two different ways. First, which is sort of probably the one you're familiar with, is write platform-specific code in a plugin and send messages back to the Flutter app via platform channels. The other way, and I guess I gave a spoiler, but the other way is to use Dart FFI to directly call C functions from Dart. What are the advantages of each? Well, the advantages of using plugins is that you're separating the platform-specific implementation from the more generalized application logic, which is in your app, right? This is sort of the secret sauce to making Flutter apps cross-platform, right? You want to isolate out everything that knows about how the platform works into plugins. That way, your actual Flutter app code is just writing more generalized, in a more generalized way, how something should work. And what's the advantage of using Dart FFI? It's faster. And if you follow the retro gaming community or the emulator community, it's all about input latency, right? So that's why I chose to use. I basically said, okay, for this game, it's not going to be cross-platform. It's going to be very specific to Linux, specific to the Raspberry Pi. But I just want to see how fast can I get this running. And now let's see the second video, which, oh, no, don't hit play yet. All right. Here we go. And all right, so this is the final iteration of my game. Again, running it in release mode and making it full screen. And we have gamepad input. It's running a little bit slower, but that's actually not because of the, as far as I can tell, it's not because of the using the gamepad. It's because I switched the orientation to portrait mode, but I thought that that would be most true to the spirit of this game. All right. And finally, any questions?
This is mind-blowing. Absolutely amazing. Okay, yes, there was a question about keyboard inputs, and I already answered that.
Okay, I'm gonna stop sharing my screen.
No, I don't think we have any. Any questions, people? Any questions? Anything? So, are you able to use the joystick?
Yes, I was able to. That last
Oops.
video, I was able to
Not
use
this
the
one.
gamepad.
Yes, this one.
Oh, one question: were you able to hook up audio? I did not. Yeah.
Yeah, that's another native integration that we would probably need.
Yeah. I think it's also. I'm a big Linux fan, a big part of the Linux community, but one of the difficulties, I should add this. One of the difficulties about distributing a Linux desktop app is there will probably be runtime dependencies, such as if you hooked up audio, like, okay, are you gonna depend on Pulse Audio and I will say, while I was working on this for the first time, I tried the Flutter Snap package, and I was very impressed. So it was because actually, I should add also, if you look in my repo, I put a script called Setup OS, which if you're going to try this, take a look at that. It has a lot of the dependencies that I had to install just to get the development, just to get a Flutter app to compile.
Nice.
But I really think that if you're going to distribute a Linux desktop app, probably Snap is the way to go, because then it will package all of your runtime libraries and dependencies for you.
Yeah, we have another question by Eric.
So my code is all open source, but it's I really coded it as a proof of concept to get it running. And I don't really have the time to make it sort of generalized. I would imagine you would want to make this because I definitely like hard coded some of the values into the particular gamepad that I had. So I would imagine you would probably want to make this like configurable at runtime. So anyone can feel free to fork my project and then make it robust and publish it as a desktop package.
Nice, nice. Yes, I imagine it could. I didn't see it properly, but I imagine that services layer on Flutter detects all kind of keyboard inputs. So probably could see something like that. I don't know.
Oh, you mean in terms of up? Yeah, I think. So I think there's some support for joysticks in Flutter, but only like as to move the cursor, I believe.
Okay. Okay.
I think that on Windows there is gamepad support, so it's definitely possible, and it's but that's above my pay grade, like actually upstreaming these into the engine.
Yes, I think it's really complex for each platform. Yes, and there's also a question by Robert Felker, who, by the way, is the dude that painted this.
Oh,
this
cool.
I forgot the name. This painting here, and it's Flutter. So I have Flutter on my wall thanks to Robert Felker. And
that's awesome.
he asked it, what's the memory consumption on this?
You know what? I did not benchmark that. My particular Raspberry Pi has 8 gigabytes, so I didn't anticipate it being an issue. But even with 2 gigabytes, obviously it depends on the game, but I don't anticipate that really being a problem. And if your particular game does have a problem, I imagine it would have that same problem on mobile, on phones.
Yes. I think it's just a matter of managing your assets in memory. So loading them and
Yes.
freeing memory. You have to be smart to not load all assets at the same time in the screen or in memory. And differently from apps, games are nice to have. It's okay to have loading screens on games.
That's true. That's a good point.
Yes. I guess that's all questions. And something else? Okay, so I will invite everybody on the stage right now. Okay, and we can have questions about V1, Flame, anything related to Flame. We already have some questions about V1 that went back in the chat. So I have this question about V1.
One thing we could mention first is the FPS counter. We're not really sure if that one is correct, right?
Yeah, that's true.
So it could be that you have better performance sometimes than it shows.
Yes, we have to reveal that the FPS counter, but it always from experience it always clamped from also the hardware. So if you are running on a simulator, it's always 30 FPS. On my phone, that's high refresh rate. It can go to 90, but our frame counter, it's not doesn't reflect the thing that the IDS shows. Okay, we have this question, Flame, about unifying. And just to be sure, the good person, the nice person of this call, answered.
Thank you.
Answered it, and basically, when we touch Flutter is always based on offset and other classes like size and stuff like that.
Yeah, but for those, we're adding extension functions, right? So the goal is everything will be interoperable with Vector2, no matter if it's offset, size, dimension, math.points.
Just don't forget to import our extensions.dart file.
Yeah.
Yeah, to use that, we have to import. Okay. Another one is about audio on V1. Are we using Ocarina or audio players?
It's not a fork of audio players. Flame Audio just uses the package audio players. That's how it's implemented, but you can easily use Ocarina as well. Like Flame Audio is a very thin wrapper of audio players. You don't need to use that. You could use audio players directly, or you can use Ocarina directly. Flame is very modular, and you can like pick what you want to use. So all options are available.
Yeah, and we have been talking from time to time to maybe abstracting Flame Audio to a common interface, so you could easily plug any audio player. So we have nothing concrete yet. We are just discussing, but this may be something that we may change in the future to allow multiple players more easily. Right? Like Lua said, you can already use any player that you want, because Flame Audio is just a very, very small abstraction on things. So yeah, that's may improve in the future.
Yeah, it does add something like audio pool, for example. So that is kind of tied to audio players right now. But if we did, like, it would be nice to have Flame Audio accept like a generic audio player, and then you could get the feature of audio pool with Ocarina, for example.
Nice. Next one is about examples of games. Yes.
That is something that we are working all the time. So we have been just recently did all our examples where you can now access online on our examples.flameengine.org. And we also are developing tutorials, and the thing is that we are focused more on view 1 now, so we don't have much time to focus on examples and tutorials and like that, but we'll work a lot more on that after view 1 is released.
Yes, also in addition to that, Barboit also added that we already have an awesome Flame, and it is, as far as I know, it is maintained.
Yes, it
so
is.
it already has some examples, some of them are open source, of what is possible to build with Flame. A little bit of a guidance.
Yeah, the examples we have. Oh, sorry, go ahead.
There's also a really good version 1 tutorial by DevCage, a YouTube tutorial on the awesome Flame repository. I would recommend checking that out if you want to have a visual tutorial about V1.
Yes, we have a more recent question about Hexagon. Is there a limit to work with Hexagon layout logic? Is more general as far as the plan support game style with libs? Anyone up to answer this?
Yeah,
I'm not familiar with that layout logic.
Yeah, it's like seems like a tile composition with hexagons instead of.
Yeah, it's like civilization map, right, where you have the hexagons.
I believe TAL supports hexagon layout. So in that sense, we do support it, right?
Tile does support it, but our tiled library is able to parse a TMX file from tiled. So if you're doing that by hand, you can support that. But our Flame tiled does not support out of the box.
That's a nice edge case.
Yeah, but on the more general question on how far we plan to support different game styles, we do plan. We already support some stuff like tiled, for example, is a very good example of lib that we support. And we are always looking forward to new suggestions of things to support.
Yes, this one is for Wolfrain, Oxygen.
Yes, technically speaking, Oxygen is already ready for use. It's already published even as Oxygen on PubDev. There's a small improvement that there's a small PR ready for the next version that I implemented because I was noticing some performance issues when I was working on the Flame Oxygen bridge. But yes, Oxygen is usable and completely null safe already, so I recommend checking it out.
Yes, and being totally platform agnostic, the example is a terminal.
Not flame agnostic, as Luan said, but platform agnostic.
So you don't even need Flutter at all. You can use a terminal on a terminal application.
Yeah. The example for Oxygen is completely written in a terminal app without any Flutter dependencies.
That's amazing.
That's really cool.
Yeah,
gotta check that out.
This one is very difficult to answer, but here we go.
The dreaded question.
Nice. I desire to know this. We all want to know this, but we can say that it's probably close, right, Luan? We have not many stuff. We already have a lot of payloads in our release candidates. So
yeah, I think we're very close. Like we have a couple of things we want to address. Like for example, Spydon mentioned that the FPS counter sometimes under reports, and we're trying to investigate why that is. So that's one of like 3 things that we have on our list. And then there's anything that comes from feedback from the community. And yeah, I mean, my best answer to that is as soon as it's ready. We don't want to release something that's not like up to standard.
But that's a good thing about working on an open source project, right? And not being paid, and you don't have to be forced to release something too early.
Yeah,
this will be better quality.
Yeah, but one thing that I think is worth mentioning is that most of the breaking changes, I think almost all of the big breaking changes that we have planned from the previous version on 0.29 and the current basically of V1 are already done. So if you want to start using V1, we can't guarantee that there will not be breaking changes in the future for the next V1, but they will be very minor, so you can safely use it as right now.
Yeah. The only really big thing, if you're using the joystick, is that will probably refactor the whole of that one. But that will be it would be quick to move over to the new one too, probably.
Yeah, I don't think there'll be any big changes to API anymore at this point.
Yeah.
Except the particle API.
Well, that's already under PI.
It's almost ready, almost.
Okay. Next
Yes.
question.
It's
Yes.
it's a
Try to answer yes.
complex game. Yes.
I'm not familiar with that particular game, but I do want to give a shout out to Bonfire, which is a library made by our friend Rafael, which vastly helps you building RPGs, especially in the style of like RPG Maker, kind of those kinds of battles. I'm not sure about this game. Maybe somebody else knows it.
Maybe that's something for Raphael to add to Bonfire.
Yeah, I just searched a little bit on Google Images, and looking by the graphics, I think it's not that hard. It's not something from other world, but I guess it would be very smartly. You should be very smart on your state management for such a complex battle. But yes, this question is about Fire Slime. Do we work on actual games, or are you 100% maintaining POC in the lib? Eric?
Yeah, we used to work on our own games. Actually, Fire Slime was born with that idea. Flame was just a side project, but now it's our main project, to be honest. And that is something that we want to get back to working on our own games and building games with Flame. But at the moment, I think it's safe to say that we are very focused on working on our open source projects. So yeah, maybe in the future, maybe after Flame V1, we have more time and we can try to get back to work on games.
And also this one. Flutter with Xbox.
Not
someone
familiar.
test? No, I
Didn't someone do that back in the days?
Yeah, I know that there is someone working on UWP platform support for Flutter, which it would be needed for work on Xbox. As far as I know, I'm not that familiar with the platform, but I don't think anyone ever tried Flame with that.
They run Windows now, right? So it shouldn't be that far off the realm of possibility.
Yeah, but Windows Desktop, it doesn't use the same platform that Xbox uses.
So
it's not so easy to just run Windows on Xbox.
Yeah, on Dev and Master now, there is UWP support. It's like brand new though, and I haven't tried it. So the answer is probably no one's tried it, but I think theoretically it's possible.
It's both WTF.
That's pretty cool. I didn't know that. I'm just gonna change my channel to Master right now and test that.
Absolutely. And I'm going to the store just to buy an Xbox.
I'll buy a Raspberry Pi for sure.
Yeah, I'm more hyped for the Raspberry Pi than the Xbox.
It's slightly more affordable than the Xbox.
Yeah.
Yes, of course. And also with Sony working on Flutter stuff. Oh, I hope someday on PlayStation. I hope. But I guess theoretically the easiest part for Flame at least would be the graphics parts, rendering stuff, because it's Flutter. But there's also the gamepad thing that we just saw, that how hard it is. So,
And audio.
yes.
To be crazy.
I think that's it for questions. I don't know. I just dropped the link for Bonfire. If you want, anyone who doesn't know what Bonfire is, want to know, it's amazing. Yep. Okay, I think that's it. Oh yeah, I have something to say. I'm very, very well dressed today because I'm wearing Flame. You can run Flame in your clothes now. You just head over to Flutter -engine.org/merch. I'm just passing.
Flame engine, not Flutter engine.
Oh, sorry. Yes. Shit. Yeah.
Can you get the Flame branded TV too, like you have in the background?
That's just my iPad projecting on my TV, so I can.
Yeah.
And yes, we have wallpapers on brand. Yes, and here's the link for the merch, and that's it. I think that's all. So time to say goodbye.
FlameCon 4.
Yes,
Thanks for
FlameCon
tuning
4.
in.
Goodbye.
Have a good one.
Bye-bye.
Good one.
Bye.